Yeah, good morning, students. Uh, Today we are going to discuss about introduction about distributed systems. The topics to be discussed today is introduction to the distributed systems and defining the distributed systems, characteristics of distributed systems, and examples of distributed systems, challenges of distributed systems, and these are the topics of first unit, first part. Okay, see about the introduction about distributed systems. First, we will discuss about we need to know what is networked computers and what is distributed systems. Okay, coming to the network of computers are everywhere. See, the networks of computers are everywhere. Let's take an example for networks of computers is mobile phone networks. These are everywhere. Corporate networks means the corporate offices, they are located at different places, but still they are connected in a network. Next, factory networks. Factories are located at different state, different places, and still they are connected by using a network. Next, campus networks, in-car networks. See the example of mobile networks where see the my mouse here. This is the caller and this is the receiver. Caller and receiver. In between the caller and receiver, you might well aware of calling station and receiving station in mobile computing. See, in between these two, we have base station where we will get the all information about the caller and receiver, and along with the base station, we will have MSC, mobile switching center. Okay, the mobile network. This is all together called as mobile network. In mobile network, we have caller, receiver, base station, and mobile switching center. Okay, this is the one example of network of computers. And other example is in-car networks. See here, this is the diagram. This is the in-car networks. Here, see in the diagram, we have three cars. These three cars are these are three different cars, but still they are communicated. This is called as in-car networks. Next, onboard networks in planes and trains. Okay, in aeroplanes and trains we have some networks. These are the some network of computers example. These are everywhere. Okay, mainly the distributed system aim is to cover the characteristics of networked and distributed computing systems. See, the networked computer and the distributing computer is very similar. Why? Because the networked computer means even though the system is in another continent, the system is in this continent, all systems are in within a building, within a city or different places, still they are communicated by using the network. Okay, our distributed system aim is to cover the all these characteristics of networked or distributed computing systems and its applications. Okay, here see the present main concept and technique has been developed to help the tasks of designing and implementing the systems and applications based on the networks. See, we have different types of communication. See, one system is at this one place and another system is at another place. These system needs to be communication. For this type of communication, we need to establish one type of network. Suppose for every type of communication, we need to establish different types of networks. This is the our distributed system aim. Coming to the definition of a distributed system, see how the systems are communicated with each other. How we both the students and faculty are communicating with each other. I am telling the topics and you are listening the topics. Here the systems, the distributed, the name itself meant for distributed, meant for the systems are located at this different places. And how these systems are communicated. These systems are communicated by using message passing. See, the same you displayed on the you will be able to see on the screen. A system in which hardware or software components are located at networked. Networked means those are connected. Those are connected. The software or hardware components are networked means connected. Okay, and they will communicate and they will coordinate actions by using message passing. Okay, in this point, the components, software components and hardware components are located at networked. Located at networked means they are not at single place, they are at different places. Still they are in communication, still they are in coordination. How these will be in coordination and communications means they will send messages. This is called as message passing. Next one, next point. A distributed system, this is the distributed system definition according to our textbook. A distributed system is a collection of independent computers. The distributed system is a collection of independent means that is autonomous computer. A distributed system is a collection of independent computers or autonomous computers that appears to the users of the system as a single computer. Okay, even though the systems are many, so many systems or so many computers are networked, so many systems are networked, but that all system all together appear to the user as a single computer. Single computer means suppose we sit at one place, we need to communicate with another system. All the system needs to be visible to us as a single computer. Let's go for example of distributed system is clusters, clouds, etc. Coming to the example, first example of distributed system, it is a cluster. Cluster means, all we know, the group of similar things. A group of similar things are called as a group of similar things called as a cluster. Okay. See, in the cluster, a type of parallel or distributed processing system which consists of collection of interconnected standalone computers cooperatively working together as a single and integrated computing resources. Okay, I hope you understand this one. A type of parallel or distributed system which consists of a distributed system is the combination of collection of interconnected standalone means standalone, independent, autonomous. These three are considered the same meaning. Computers are cooperatively working together. How they are cooperatively working together? By passing the messages among the network. In the network, they are passing the messages, working together as a single integrated computing resources. I already told you the all distributed systems view to the user as a single system. Okay, this is the one first example of cluster. First example of distributed system names as cluster. Second example of distributed system is cloud. All I hope I all we might aware of cloud because you have completed cloud computing. Okay, see here how the cloud is related to distributed systems. I will tell you. A type of parallel and distributed system consisting of a collection of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources based on service level agreements. See, cloud means here a type of parallel or distributed system. This is consisting of, in the previous cluster, what I told you, a collection of interconnected standalone computers cooperatively working together. Here in this cloud, what I am saying is the collection of interconnected, same, the collection of interconnected. In the previous one, standalone. Here what I am saying, interconnected and virtualized computers that are dynamically provisioned and presented as a one or more unified computing resources based on the service level agreements. Okay, here in the previous one it is as a single integrated computing resource, that is a standalone. Here the difference is it is the virtualized computers that are dynamically provisioned. Okay, hope you understand about cluster and cloud. These two type of systems comes under the category of distributed systems. The distributed itself meant for, please remember the students, the distributed itself meant for The distributed, the components are distributed, located at different places, that all connected in a network, that all seems to be a single system to the user, that is called as a distributed system. Here see the next one, the networks. What is the networks and what is the distributed systems? Networks versus distributed systems. See, coming to the network, a media for interconnecting local and wide area computers and exchange the messages based on protocols. All we know about this one. A network itself, it is a media to communicate the systems. How the systems are communicated, those systems needs to be connected in a network, then only those two systems are communicated. Those two are any systems, any number of systems needs to be communicated, they must be in a network. Okay, how they are communicated? So see, the network entities are visible and they are explicitly addressed. Every network computer is explicitly addressed, means every network computer is having an address. That address, what we call here, is IP address. This is about network. Coming to the distributed system, the existence of multiple autonomous computers in a transparent, told you, autonomous, standalone, independent, these three are same. Existence of multiple autonomous computers in transparent. Okay, see, however, we have some problems mentioned here. uh, the example is openness, reliability is the common, but at different levels. In the distributed systems, we need to have, why? Because the reliability plays an important role, because here the computers are connected in a network, located at different places. Those needs to be communicated. In the communication, the major aspect we need is reliability. Okay, here next one, the networks mainly focuses on packets, routing, etc. Okay, you learned about network layer. Okay, here the network layer the network mainly focuses on packets, mainly focuses routing, whereas the distributed system focus on applications. That is the difference between network and distributed system. The network concentrates on routing and packets, whereas the distributed system focuses on applications. And last one, every distributed system relies on services provided by a computer network. Okay, for a distributed system, we are saying it in the word distributed system. For that word, what we will need, the computer network must provide services to that system. Then only it is said to be distributed system. Without computer network, there is no distributed system. Next, see the reasons for distributed system. See, the first reason for distributed system is the functional separation. TLC, functional separation. See that the diagram on the top side, top right. Here we have some stations, and this is the where the mouse is point. My cursor is pointed. This is the central computer, and these are the rest of four are the workstations or terminals or stations. See, the functional separation is nothing but existence of computers with different capabilities and purposes. See, these stations, these four workstations are having different capabilities, and this one is having different capabilities. Why? Because this is a central computer or a server. These are all the four are all the four are workstations, that is clients and let us assume these are the clients and servers. These two works for a different purposes, capabilities are different and purpose is different. The server capability is different, the client capability is different. And next one, the coming to the purposes, the client works for the data processing, the data collection and everything. clients and servers, these two are works for data collection and data processing. Okay, this is called as functional separation. This is the first reason for distributed system. Next one, inherent distribution. Okay, inherent distribution, this is the second reason. See, the first one, different information is created and maintained by different people. That is right. Different information is created and maintained by different people. Example, web pages. By using web pages, we can collect the collect the information from different people, and collect the different types of information. Next, information about the information and about the people. The computer supported collaborative work. Now coming to the people, some might work as virtual teams, some might work as engineering teams, virtual surgery teams, like that. This is about the separation of, this is distribution, people distribution. This is the information distribution. Information distribution, suppose let's take an example. uh, Information distribution means, let's take in our college example. CSE information is collected by, maintained by CSE HOD. ECE information is by ECE HOD, like that, and so on. Coming to the people, different team of people. See, computer supported collaborative work. The work is same, but the people are different. Virtual teams. Some people might work as virtually. Some people might have engineering teams, etc. Next, here see, next one, power imbalance and load variation. This is the third reason for distributed system. Power imbalance and load variation. See, the distribute computational load among the different computers. Here see, power imbalance and load variations means, in a distributed system, different workstations, different terminals, some some central computers are takes place. We need to do is distribute the computational load among the computational load must be distributed among the all workstations distributed in a network. Next one, for reliability, long term preservation and data backup at different locations. Different locations means, the same, suppose one information is located at one place. If any, either if any problem occurs, a system crashes, the data will be lost. In order to uh, adjust, in order to cover that issue, what we will do is long-term preservation of data and data backup. For the data backup is not done at one system. The replication, hope all you know about replication. Replication is nothing but the duplication. Okay, the same data, the same data, that is the replica, will be stored at different locations. If at one location the data will be lost, the same replica will be stored in at another place. Okay, like that. That is for the reliability issue. Economies. Next, last reason is economies. Sharing a printer may you, suppose simple thing, this is all we are in the class also. I told you about this thing in computer networks also. Suppose 10 systems are connected in a LAN or a network. Suppose any system needs to take a printout. No needs to install a printer for each system. Instead of that, what we will need is, for a single printer is shared among all workstations. Okay, that is the, see, mentioned here. Sharing a printer by many users and reduce the cost of ownership. Okay, see here, this is the, see this diagram. All these terminals are connected to this one. Okay, building a supercomputer out of network of computers. Okay, see, this is a supercomputer. How this will become a supercomputer? Okay, all these systems are connected to this one. Okay, next, this is the reasons for distributed systems. The next one, next topic is, what are the consequences of distributed systems? See, the computers in distributed systems may be on separate continents. I hope you are, understand. The computers and distributed systems may be on different separate continents in the same building. They might be in the same building, they might be at separate continents, separate states, separate places, or the same room. Suppose, let's take an example of our laboratory. All systems are connected in a network, all are in one room. That is also distributed system. In different continents, one is in Asia, one is in Africa, one is in Atlanta. That is the distributed system within the same building at different rooms. That is also a distributed system. Okay, for all these categories, the distributed systems have the following consequences. Okay, see, the consequences are: first one is concurrency. Concurrent means, already I told you so many times, the concurrency is nothing but simultaneous. Each system is autonomous. Each system is independent. Each system is a standalone computer. That means autonomous means they might carry out tasks independently. Each system can work independently, and the tasks coordinate their actions by exchanging the messages. In the first slide, I told you how these the distributed systems are communicated. The distributed systems are communicated by passing the messages. By passing the messages, they will coordinate each other. They will coordinate each other. This is about concurrency. Next, heterogeneity. Homogeneous means same. Heterogeneity means different. Why? Because these are different systems, different places. Might be on same place, same room, same building, at different continents and different states at every given. All these are heterogeneous, independent terminals. Okay, there is no global clock. There is no global clock for these connected distributed systems. And the failures also independent. the, the meaning of independent failure is nothing but, see, the below diagram here. This is the central computer or server. These four clients are connected to this central computer. If one system may fail, that is independent. The failure doesn't impact on another system. Okay, the rest of they will be working fine along with working with the central computer. Okay, this is the meaning of independent failure. The failure of one system may not affect the other system. Okay, these are the consequences of distributed system. Next one, characteristics of distributed systems. First one, parallel activities. Parallel activities means all connected networked computers are worked independently. Means they might do their own work. They might be autonomous systems, they might be standalone systems. These systems autonomous, they might work independently, or all are working parallelly. Okay, all are working parallel activities. Next, second characteristic is communication via message passing. Okay, already told you there is no shared memory among the systems. What they will do is they might share the messages. They might share the messages to coordinate one with another. The distributed computers share messages to one another for coordination. There is no shared memory. There is no shared memory. Next, resource sharing. Resource sharing means, suppose one database can be shared among different workstations. One printer can be shared among different systems. Okay, from any place. So let's take an example. Some systems are connected in a room. If from any system we can give the print. Okay, that means the printer is shared among the all workstations. Next, there is no global state. No global state means no single process can have knowledge of the current global state of the system. That means each system works independently. Each system can perform parallel activities. Each system can do individual activities, so that No other system, no single process can have the knowledge of the current global state of other system. Okay. Next, no global clock. Only limited precision for the processes to synchronize their clocks. There is no global clock. Already in the previous section also I told you in the consequences of distributed system, no global clock. The same I mentioned here. Only limited precision of processes, limited precision for the processes to synchronize their clocks. These are the characteristics of distributed systems. First one, parallel activities, communication via message passing, resource sharing, no global state, no global clock. Next, goals. Coming to the goals of the distributed systems, we have 5 goals. First one is connecting users and resources. Connecting users, that means resources and users, that is to share the resources among the users. That hope you understand, to share the resources among the users. That is the reason why connecting users and resources. This is the first goal of distributed system. Next, transparency, openness, scalability, enhanced availability. These three diagrams are, see, these all three are the distributed systems example. Here, see, this is the well known to us. So many slides we have seen this one: workstations and central computer, and this is the supercomputer. See, this is this one. This one is the local server. The green circle, green dotted circle is the local server. This is the external LAN. This is the external LAN, and this is the server, and these are the different databases. Okay, this is also comes under distributed system. Some examples of distributed systems are, the distributed systems are based on see, first one, distributed systems are familiar and widely used computer networks. Okay, I hope you are all know about distributed systems are all, but every networked system uses the distributed system. Every distributed system needs a computer network. Okay, examples are internet, intranet, and wireless networks. See here, this is an internet. To this internet, see, personal computer, mobile, database, remote server, remote desktop, notebook, all are connected to the network. This is also a distributed systems. Why? Because this is a distributed systems to internet. All these are connected. Okay. Next one. Examples of distributed system and its applications. Web. Web is one example. Data centers and clouds, wide area storage systems, banking systems, and user level communication, like Facebook, Zoom. This is the user. Suppose we are, the best example for distributed system is present. You are listening the class in a, you people are sit at your home place, home location, at your home, and I am at different location, you are at different location, still we are communicating with each other with the coordination. This is the best example of distributed system. Still, we are at different places, still we are connected to each other, and we are in a coordination. This is the best example of distributed system. The Facebook is the one of the user level communication application, and WhatsApp and everything, Zoom. Okay. Okay, in the tomorrow's class, we are going to discuss about some selected application domains and associated networked applications. Okay. Thank you, students. Okay, see, one point you need to note down is, from tomorrow